Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, today we are starting another sum of supported at same level in 3 hinge arches. Let's see in details. It's very simple questions which is come in the exam 10 to 15 marks. It's very simple, so please sit back, relax and watch till the end. Let's see. Now see, this is the question given to us. A 3 hinge parabolic arch with rise 4 meter and span 20 meter carries UDL of 20 kilonewton per meter from the left half. If it also carries a point load of 50 kilonewton on the crown. Now calculate the reaction and horizontal thrust, bending moment at 4 meter from the left hand, the normal thrust and radial shear force at 4 meter from the left hand, maximum positive and negative bending moment, and draw bending moment diagrams. In these types of problems is compulsory questions which has come in the exam is reaction and horizontal thrust, normal thrust and radial shear force, and bending moment diagram. Or you can see both 5 also is also coming over here. Now in the question we don't have given the diagram, so first step is nothing but draw the diagram. Let's see how will you draw the diagram. See, a 3 hinge parabolic arch with rise 4 meter and span 20 meters. So draw it. Now see, this is your arches. This is arch, this is A, and this one is B, and this is C over here. Okay, now then the span will be 20 meter. This is a 3 hinge. Now see, and it carries a UDL of 20 kilonewton per meter from the left half. Means from the left half is nothing but this one is also carrying a UDL also. Okay, its intensity will be 20 kilonewton per meter. Now after that, see, it also carries a point load of 50 kilonewton on the crown. So let it draw. This is nothing but 50 kilonewton on the crown. H is 4 meter, span will be 220 meter, and this A and B, and this one is C. Now let's start with the first one. Now first one is nothing but find reaction and horizontal thrust. So let's start. First part will be reaction and horizontal thrust. Reaction and horizontal thrust. So first of all find the reaction. In reaction, see, in reaction this is your hinge and this is also a hinge, so it will come like this. Reactions will be like this. VB, as you all knows, in arches H is always inward, so HB HA. Okay, now solve the VA and VB reactions while using. Now what you are taking first, taking moment at A equal to 0, so take it over here. Taking moment at A equal to 0, sign convention is nothing but clockwise positive. Okay, clockwise positive. So how will you take this? See, this first of all we are taking moment over here, so this UDL is come in the picture. 20 into 10 into 10 by 2 in clockwise direction, so positive. 20 into 10 into 10 by 2, this is nothing but UDL. Okay, now this point load is also going in the clockwise direction. See, how will you show the clockwise direction? So take a rod and put it over here and fix it at A, as we are taking bending moment at A. So 50 km is going in clockwise direction, so positive 50 into 10 plus 50 into 10. After that what is come left is VB. This is nothing but VB into this 20 minus VB into 20. While solving this you get the value of is equal to 0. While solving this you get the value of VB. Your VB value will be 75 kilonewton over here. Okay, now done with the FA part, moment A. Now after that what is our next step will be summation Fy. Summation Fy equal to 0 upward positive in vertical in y direction. In summation Fy always take the only reacts, always take this value supports also. Okay, no need to into with the distance, so please listen carefully. For vertical members only take the members. Okay, now see how will I take this. See, we got the value of VB will be 75 kilonewton. Okay, now always take the force, not take the distance, always take the only force in Fy. So what will come, this VA plus then minus 20 into 10 then minus 50 plus 75 equal to 0. While solving this you get the value of VA will be 175 kilonewton. Okay, you got the value of VA will be 175 kilonewton. Okay, now after that, now we have to find the H. Now in this chapter, while finding the H value, always take the bending moment at the center, means C. Then we got the value of H. Because it is indeterminate structure, we have to, for determinate we have given this hinge over here. That's why we can take bending moment over at C. Either you can take AC part, either you can take CB part. Which one is simple, that take that part only. Okay, so here we can take in, here we have taken this part C and B because it's not complicated. In exams to save the time, save the minimum loading part. Okay, now okay, now see, bending moment at C equal to 0. As you all know, the sign convention is like this. This is sagging positive, hogging negative. Okay, hogging negative. Now see, when you are taking bending moment at the center, either you can take AC part, either you can take CB part. Which one is simple, you can take that part only. Okay, now I am considering C and B part over here. So when we are taking bending moment over here, we are taking section over here. So what's the value will come, this will go in this direction, means plus. So 75 into 10, 75 into 10. Okay, after that see, this H is also coming in this picture. So how will you know this H value is plus or minus? What you have to do over here is just simply open the arch. If you open the arch, your H will come like this. Okay, section this side, this will go in this direction. So minus HB into perpendicular distance will be 4. So minus HB into 4, minus HB into 4 equal to 0. While solving this you get the value of HB will be 187.5 kilonewton. But as you all knows, in arches both the H are same. So HA is equal to HB is equal to 187.5 kilonewton. This is your answer. Okay, now put it in the value over here. 187.5 kilonewton, 187.5 kilonewton. Okay, okay, now after that we have done with the first part, and our next is asking in the question is bending moment at 4 meter from the left hand. Okay, so let's take this one also. Second one will be, our next step will be a bending moment at 4 meter from left hand. Okay, 4 meter from left hand. 4 meter from left hand means we have to take with A as bending moment at 4 meter from A. Now what we have to do over here is just see the diagram, and we have to find the bending moment at 4 meter from the left part. So just draw the FDD of the left part only over here. Now draw over here left part only. Okay, now we have to find the 4 meter. This is here nothing but your 4 meter. This distance is nothing but 4 meter. This distance is, we don't know, this distance is nothing but y. We have to find at this point, this is nothing, name it as d. We have to find at d the bending moment. This is 4 meter. As you all know, this value you know, and this is also you know the value. 175, 187.5. Okay, now we have to find this intensity will be 20 kilonewton per meter. Now we have to find bending moment at D, means you are taking section over here, so we have to take this one only. Okay, so consider part A and D with A as origin. This is your origin A. Okay, origin A. Now how will you take this? Write this. See, you can write bending moment at D equal to, how it will calculate, 175 into 4. After that, this minus 187.5 into y. Then UDL also come in the picture, so minus 20 into 4 into 4 by 2. Name it as equation number 1. But we don't know the value of y. So for y, what, as you all knows, for y, what I am explaining you, use the formula of y. Y is nothing but y is equal to 4h upon L square into Lx minus x square. So write over here, y is equal to 4h upon L square into Lx minus x square. Simply put the value of x is equal to 4 meter. Put the value in y and we got the y is equal to 4 into 4 upon L will be 20 square into 20 into 4 minus 4 the whole square. While solving this, you get the value over y will be 2.56 meter. Okay, now this value put in equation number 1. Okay, put in equation number 1. The equation number 1 will be this. So bending moment at D will be 175 into 4 minus 187.5 into y. Instead of y we have to put this value 2.56. so 2.56 over here. Now minus 20 into 4 by 2. You are solving this, you get the value will be 60 kilonewton meter. Okay, now you can write bending moment at D will be 60 kilonewton meter. Okay, 60 kilonewton meter. So write it over here, bending moment at 4 meter from A will be 60 kilonewton meter. Okay, now we have done with the next part also. Now let's start with the third part. Normal thrust and radial shear force at 4 meter from left hand. This is exam point of view, this topic is very important to come in the exam. Okay, so let's see. Now to solve this, now third step will be Okay, now see, to solve this normal thrust and radial shear force, we have logic also and formulas also. I will explaining both of them. Whichever you have convenient, you can use this formula also or this logic also. If you not remember the formula in the exam, you can use the logic. If you remember the formula in the exam, you can use the formulas in the exam. Okay, now let's first see with the logic. Now see, we have to find the 4 meter from it, that is nothing but your D part, means we have to find over something here, something over here. Now just draw the only 4 meter FB diagram like this. Just zoom it this part and just zoom it this part and zoom this arch line also. Okay, so how it will look like this is like this. Now see, this is your arch, you are zooming. Okay, now see, this is your main arch line. Okay, now how will you draw the, now this you have know this value over here. This is nothing but 175 kilonewton. After that you know this one also. Now see in it what is nothing but is UDL also given over here. This is nothing but 4 meter. Okay, now what you have to do, now what is normal thrust and radial shear force? See, take a one tangent line over this center, take a center line, tangent line over this center. Okay, take a tangent line over this center, and this tangent line is nothing but your normal thrust. Okay, and perpendicular to this is shear force. Okay, this is normal thrust and this is radial shear force. Take a tangent line on the center of the line. This is nothing but normal thrust to this perpendicular line. This is nothing but radial shear force. Now balance the equation over here. So how will you balance this? Now to balance this, see this 175 going from down to up. So right over here, net unbalanced vertical force. So consider part DA. This is A and this is your D part. Okay, DA is, now see, this 175 is going upward, minus 20 into 4 is equal to 95 kilonewton. Now you got the V value is 95 kilonewton. So see, 175 is going from upward, so V is coming from downward, so it will look like this, 95. And this H, in H there is also only one load, 187.5. To balance this, okay, now see, this 95 why coming downward? See, 175 is going upward, 95 plus 20 into 4 is nothing but 175 going downward, means its part will be now balanced. Now here H value will be, your H will be, this V will be 95, H will be 187.5 kilo Newton. Please remember this used for the formula. At the time of formula, this will you can use a V and H. Okay, now we have to find the theta. Now how will you take the theta? See, this is your 95 kilonewton. Take theta from this to left side, this to left side. See, point from left side is nothing but your thetas. Now let's write the equations of normal thrust and radial shear force while seeing this diagram. Now first read the ND equation. ND is nothing but normal thrust equation. Now first one is nothing but ND is nothing but normal thrust equation. For normal thrust, see, this 87.5 resolve into this 87.5 resolve into N, this 95 resolve into N, because we are finding the N equations. Okay, N is nothing but normal thrust. Okay, so see, this 187.5 when go in this direction, this is with respect to theta is going, so 187.5 cos theta, 187.5 cos theta in going in this direction. Okay, now see, if your 95 is this, resolve 95 into this direction, with which is not with respect to theta, that's why 95 sin theta, 95 sin theta is also going in this direction. See, both the direction are same, so that's why in between you can write plus. Okay, now what are the formula of ND? You also write formula of ND will be H cos theta plus V sin theta. This is nothing but your formula. Now same you get well by logic also, and you get the by formula also. Now leave 3 to 4 line space and write the equation of radial shear force. After that we can find theta, then put it over here and solve this. Okay, now see, now F line will be nothing but this one. Now this both of them we can resolve in this line. So see, this 187.5, this 187.5 resolve in this direction. See, this direction, like this, resolve in this direction like this. So it will come, sorry, this 95 first resolve in this direction, this will go with respect to theta, that's why 95 cos theta, 95 cos theta in this directions. Okay, now see, now this 187.5 resolve in this direction, this, so it will come not with respect to theta, that's for 187.5 sin theta. Okay, now see, both sign are upward, this is going in downward, this is going upward, so in between you can write minus sign. Now in formula of FD will be, FD formula will be V cos theta minus H sin theta over here. Okay, this is a formula. Okay, this is a formula, this is nothing but sine. Okay, this is H sin theta. Now after that we don't need the, we don't know the theta value, so how will you find the theta? So to find the theta, as you all knows in this chapter, you have find any unknown, just simply write the formula of y, 4h upon L square into Lx minus x square. Okay, now how will it write this? See, this is your arch. If this is your arch, take one tangent line, and this theta, we have to find this theta. This is dy, this is dx, this is theta. As you all knows, tan theta is nothing but dy by dx. Okay, tan theta is nothing but dy by dx. So put the value of y over here, y is equal to 4 into 4 upon 20 square into 20x minus, or please listen carefully, don't put the x value, as you all know the x is 4 over here, so don't put the x value, because if you put the value of x, we got the y, but we don't want the distance, but we don't want this just y distance, we want theta. So don't do the x is equal to 4, don't use in this equation. Okay, now what in previous sum we can using this x is equal to 4. Now see, y is equal to 4 into 4 upon, don't put the value of x, please listen carefully, don't put the value of x, but we don't want, because we don't want y distance, we want theta over here. After that what you have to do is differentiate with respect to x, so what will get? See, y will come dy by dx is equal to 1 upon 25 20x minus 2x, 20x minus, sorry, this 20 only, because it is derivating we are taking, only 20 over here, 20 minus 2x, so dy by dx is equal to 1 upon 25 20 minus 2. Now put the value of 4 at x is equal to 4 meter. Now put the value of x here, x is equal to 4 or 2 into 4. Okay, so now tan dy by dx nothing but tan theta is equal to, while solving this you get 0.48 over here, so theta is equal to tan inverse of 0.48. So theta will be over here 25.64 degree. Now we got the theta over here 25.64. Put this theta into this equations. Now this will come 187.5 cos 25.64 plus 95 sine. While solving this, you get the value will be of ND is nothing but 210.14 kilonewton. Okay, in this direction means positive. Okay, now after that, just put in over here also 95 cos 25.64 minus 187.5 sine. Okay, so here we get the value of FD will be 4.51 kilonewton. Okay, in this directions. Now we have done with the normal thrust and radial shear force also. See, this is the formula. If you remember this formula, then you don't need to remember this logic over here. This whole complicated logic. This not complicated, is quite simple in this chapter, but we are getting complicated because we could not do the in simple way. Okay, this is a very simple way, so you can apply this practice 1 and 2 times and get the knowledge. Okay, or you can have, or you have, if you remember the formula, you can use the formula in exam for saving the time. Okay, now after that we have done with the third part also. See, now we have done with this part also. Normal thrust and radial shear force at 4 meter from the S. Always remember one thing, in question always you have given the distance. Whilst when we are finding normal thrust and radial shear force, always see the if distance is given or not. Always given the distance, then only you can find the normal thrust and radial shear force. Now let's move to other. After that, maximum positive and negative bending moment. Now let's see what is maximum positive and negative bending moment over here. Now let's see the next topic. Now next topic will be our step number, okay, maximum positive and negative bending moment. In this what you have to do is nothing but, see, in this part what you have to do, just consider one time AC part, just consider one time BC part, and you will get the value. Say this part is maximum or this part is maximum. Whichever the maximum load is there, that part is maximum, and whichever no load is there, this part is minimum. So simply draw the FBD first. Draw the FBD of this part, left part first. Now what you have to take, simply take one section randomly over here. We are taking this one is nothing but A and this is C. Okay, now randomly take one section over here like this, and this distance is your X and this distance is your Y. Okay, this distance is X and this distance is Y. Now take bending moment over here. Okay, so write it over here. Take section XX, distance X from A. This is X and X. Okay, X from A means right name it as. Okay, after that, now part this is as suppose X, so XA. Now take bending moment at over here. So as you know, the sign convention is this. Now how will you take? See, bending moment at X. Now write it over here. Bending moment at X is equal to 175 into X. Okay, minus 187.5 into Y, then minus 20 into X by 2. This is nothing but UDL part. Okay, this name is as equation number 1 over here. But here we don't know the distance of y, we don't know the distance of x also. So what you have to do at that time, we know that y is equal to 4h upon L square into Lx minus x square. Simply put the value over here first. So y is equal to 4 into 4 upon 20 square, 20x minus x square. Okay, now this, put this y in equation number 1. Put y value in equation number 1, means in this equation you can put the value of y. So our bending moment at x will be 175 into x minus 187.5 into 1 upon 25. Put this 1 upon 25, 20x minus x square. Okay, while solving this you get the value over here is also 1 upon 25, 20x minus x square. Okay, so after that see, you also have this one is also there. So 2 ones are, so this cut it over here, 2 ones are and 2 tens are. Okay, so 10x square. Okay, so minus 10x square also over here. Now after that one main part, for mx to be maximum, for this part to be maximum, d by dx of mx is equal to 0. We have to take the derivative of this part and equate it to 0, because see, all the values are come in terms of terms in x, so we got the value of x over here. So derivate once time. So how it comes, 175 minus 187.5 upon 25, 20 minus 2x minus this will come 20x is equal to 0. While solving this you get the value of x will be 5 meter. So now put x is equal to 5, put x is equal to 5 meter in bending moment at x equation, means in this equation we are putting, in this equation we have to put the value of x, put the value of x in this equation. Okay, so after that how will you get the answer? Bending moment at x equal to 175 into 5 minus 187.5 into 1 upon 25, 20 into 5 minus 5 square minus 10 into 5 square. So bending moment at x will be over here, m max is equal to 62.5 kilonewton meter. Now see, bending moment at m max is 62. Now see friends, 62.5 kilonewton means coming in positive, so it's maximum positive bending moment. Okay, so right over here maximum positive bending moment is equal to 62.5 kilonewton meter occurring at 5 meter from A span CA. Or in negative bending moment you can directly got the value negative, minus. So as you remember, as you know that which is positive and which one is negative over here. Now let's take the another part, nothing but, now we are taken A and C part, now take B and C and B part. So consider part C and B and draw the FBD of the CB part. Now just randomly take the section over here, XX, distance x from A Okay, now we have to take bending moment over here. So part XA, sorry, XB. Okay, sign conversion. Okay, so now what it comes, bending moment at x is equal to, we have to take moment from here. So what's the value comes, 75 into x minus 187.5 into y. 75x minus 187.5 into y. But in previous questions we can find y, but we know that y is nothing but 4h upon L square into Lx minus x square. Okay, now see, this is nothing but equation number 1. So this will come 1 upon 25 20x minus x square. Put in equation 1. Okay, put in equation 1. So what will value will get, bending moment at x is equal to 75x minus 187.5 into 1 upon 25 20x minus x square. Okay, 20x minus x square. Now as you all knows, bending moment at x to be maximum, we have to derivative one time, d by dx of mx equal to 0. We can equate with the 0 over here. Now see, we have to derivative of this part. So 75 minus 187.5 upon 25 as it is, this is 20 minus 2x is equal to 0. Now we get the value of x value will be 5 meter. Now put in this equation, a value of 5, put in this equation and you get the value. So bending moment at x equal to 75 into 5 minus 187.5 upon 25, 20 into 5 minus 5 the whole square. Okay, so mx will be minus 187.5 kilonewton. Now see, this automatically get minus, come minus, so that is maximum negative bending moment is minus 187.5 kilonewton meter occurring at 5 meter from B span C and B. Okay, C and B. Now this has got the minus, means this is for maximum negative bending moment, and this got weakless, this is maximum positive bending moment. After that you have to draw the diagrams. So there are two types of draw the diagram. There are two types to draw the diagrams. Always remember, two types. I'm explaining both of them. You can, in exam you can draw only one also. One type is simply draw one line. Simply draw one line and take one arch over here like this. Okay, this is your arch, this is your A value, this is your B value, this is your C value. Now see the diagram. Now in diagram, see, this is a UDL. UDL is nothing, or this is a maximum positive bending moment over here. That's why this will come like this. Okay, this will come like this, and here there is no load. That's why this is your positive and this is your negative. Now write the value over here. This distance will be 5 meter. So 5 meter, write the total span 20 meter. Now this is your bending moment diagram. This is a one type, means first type is this. Now in next type, in second type is nothing but, in second type, see, in second type draw the diagram. Okay, now see, this is your A part, this is B part, this is C part. Now see, in A to C we got the value is UDL, so directly draw the UDL over here and joint it in B. And in next one, in second part we have got the point load over here in this part. So draw the point load till C, and then joint it. And this is the another part. So this is your positive, this is your negative. Now we got this value. This is 5 meter. This is 5 meter. Now this value you got over here 62.5 kilonewton meter. This value you got 187.5 kilonewton meter. This is your second part. Your span will be 20 meter. This is bending moment diagram. Finally we done with this problem. It's very lengthy problem. It's very simple. So you can in exam I am just recognized you that you can draw this diagram. Is very simple. Just draw the arch. This is UDL and this is point load, and write the value over here 62.5 kilonewton meter and 187.5 kilonewton meter. Now this is your questions. So in that, for maximum positive negative bend, you take section AC part and BC part. Okay, and after that take one section randomly and take that section. From section take the bending moment over there. Okay, now we have done with this problem. I hope you understand my videos. Subscribe the Ekeeda channel and please share with your friends to better understand. Thank you.